Good day everyone, today's video is about solving annuity problem. Clap. First, what is annuity? When you say annuity, it is a series of equal payments at regular intervals. Now let us define the other terms for the annuity. Term of the annuity. It is the time from the beginning of the first payment period to the end of the last payment period. Now, when the payment were made at the end of the payment interval, we call it as the ordinary annuity. However, if the payment were made at the beginning of the payment interval, we call it as annuity due. Now, when it comes to the simple annuity, if the payment interval equals to the compounding interval, example, if the payment were made monthly and the interest is made compounded monthly, they are the same, we call it as now the simple annuity. On the other hand, we call it as the general annuity, which defines as the payment interval differs from the compounding interval. Meaning to say, the payment interval are different to the compounding period. Example, monthly payments, but interest is compounded semi-annually. At this point, let us consider this problem to enlighten ourselves about the different terms. The problem is, I will invest 200 pesos per 2 months for my retirement at 6.25%, compounding bi-monthly for 25 years. I have a choice of making the payment of 200 pesos at the end of the bi-monthly or the beginning. In which account will I have more money and by how much? At this portion, let us now try to solve the problem in this process. So, we're going to divide the slide into two columns. The left side is solving for the ordinary or regular annuity. On the other side, we're going to solve for the annuity due. Remember, when the payment were made at the end, it's about ordinary. Otherwise, if the payment were made at the beginning, it's about annuity due. Now, let us try to list down all the important details on this middle part. Now, the periodic payment is 200, so that refers to the letter P, 200 pesos. And the payment were made every 2 months, so that is the letter M. In a year, there are 6 times. Now, the periodic interest rate is 6.25 rather, or also expressed as 0.0625. And the number of years of payment is 25 years. Now, remember that to solve for the ordinary annuity, the formula must be future value is equals to the product of periodic payment times 1 plus the quotient of j over m to the power of the product of mt minus 1 over the quotient of j over m. On the future value of the annuity due, the FB is equals to the product of periodic payment times 1 plus the quotient j over m raised to the power of the product of mt plus 1 minus 1 over j over m, then the result subtract to periodic payment. Okay, first let us try to solve the ordinary annuity by substitution. Okay, so now let us have FB equals the periodic payment is 200 pesos. Okay, 1 plus J is 0.0625 over 6 raised to the power of 6 times 25 years minus 1, then over the quotient of 0.00625 over 6. Okay, using our cell phone, let's just try to follow this process. First, we're going to solve the numerator part. Then here inside the bracket over the denominator, which is in the form of fraction. Okay, how? The first is, let us try to get the quotient of 0.0625 divide 6. The answer must be 0.0104166 and so on, plus 1. The answer must be 1.010416 and so on. Raised to the power. Press XY to your cell phone. That means raised to the power. We know that 6 times 25 is 150. That makes it as 150. Okay, the answer must be 4.73, 23, 31, 76, and so on. Okay, do not round it off yet. Retain the answer. Then after that, minus 1. We have now 3.73, 23, 31, 76, 84, and so on. Now, let us use the process in this way. Instead of dividing it, we're going to multiply it. In short, you're going to reciprocate the denominator and proceed to multiplication. So instead of dividing, we're going to multiply it. Now, the result must be multiplied to the 6. Okay, then after that, we have the product of 22.39, 39, and so on. Then right after that, divide into 0.0625. The answer is 358.3038 and so on. The last part is we're going to solve it to the periodic payment of 200. So multiply to 200. The result is 71,660.76995403, or we have 71,660.77 pesos rounded up to the nearest hundreds. So that is how we solve the future value of ordinary annuity. Now let's proceed with the annuity 2. Let's do the same. Let's do the substitution. Okay, so here let us write FB equals, again, the periodic payment is 200 pesos. 1 plus 0.0625 rather, okay, over 6 raised to the power of 6 times 25 plus 1 minus 1 over 0.0625 over 6. Then after that, subtract to 200 pesos. So again, let's go in this way. First, we're going to solve the numbers inside this bracket. Okay, first, press 0.0625 divide 6. The answer is 0.0104166 and so on. Add to 1. The answer is 1.0104166 and so on. Then press the XY, which means raised to the power. We know that 6 times 25 is 150. Add to 1, that is 151. The answer is 4.78162689 and so on. Then subtract to 1 minus 1. The result must be 3.7816268910 and so on. So instead of dividing it, we're going to multiply it. So multiply the result to 6. The answer is 22.68976134 and so on. Then divide it to 0.0625. The result is 363.036181 and so on. Then after that, we're going to multiply it to 200. We have now 72,607.2363 and so on. Then subtract to 200. Okay, the result is 72,407.2363077 and 2, or we have 72,407.24 pesos. Based on the result, annuity due is more than the ordinary annuity. Of course, we're going to subtract 72,407.24 in order for us to know on how much is you're going to gain if you're going to take the annuity due than to the ordinary. So that is 7, this is 4, this is 6, this is 3, or rather this is 4, it should be 4, and this is 7. So we're going to have a difference of 746.47 pesos. Thank you and God bless everyone.